Bismillahirrahmanirrahim. In this lecture, I am solving problem 3.49 from the book Thermodynamics in Engineering Approach by Sengel 9 edition. So, statement of the problem is water is boiled in a pan covered with a fully fitted lid at a specified location. Heat is supplied to the fan by a 2 kilowatt resistance heater. So heat of the resistance heater, Q of the resistance heater is equal to 2 kilowatt. The amount of water in the pan is observed to decrease by 1 point mass decrease in the pan is 1.19 kilogram in 30 minutes. So time is equal to 30 minutes, and 30 minutes is equal to 30 multiplied by 60 seconds, which is equal to 1800 seconds. If it is esteemed that 75% of electricity consumed by the heat transferred to the water, it is heat. It means this is the efficiency, electric efficiency, which is electric efficiency is equal to 75%, which is equal to 75 divided by 100, which is equal to 0% mean out of 100, which is equal to 0.75 consumed by the heater is transferred to the water as heat. Determine the local atmospheric pressure and that location. Required is to find the atmospheric pressure. So here we find the solution. So heat transfer or power transfer, you can name this. There's a heat transfer of electric resistance, this is Q, or you can name this as power. Heat transfer or power transfer of electric heater. Power or heat transfer to the water from the heater is 2 kilowatt. So first we find the power transfer to the water. So this is power transfer by the heater, and now we are finding the power or heat transfer of the water. So we know that electric efficiency is basically equal to output divided by input. So power transfer to the water, this is basically output, and power transfer by the heater, this is basically input. So P of water, cross multiply this equation, electric efficiency multiply by power of heater. So electric efficiency is 0.75 and power of heater is given to us as 2 kilowatt. So power transferred to the water is equal to 0.75 multiplied by 2 is equal to 1.5 kilowatt, and kilowatt is also equal to kilojoule per second. Now total heat transfer to the water in 30 minutes is, now total heat transferred because time given to us is 30 minutes, total heat transferred to the water in 30 minutes is Q is equal to power transfer to water multiplied by total time. So Q is equal to power transfer to the water is 1.5 kilowatt, kilo, and watt is equal to joule per second, and time 30 minutes is equal to 1800 seconds. So this second will be cancelled with second, and heat transfer to the water is equal to 2700 kilojoule 2700. Now we can find latent heat of vaporization. Now latent heat of vaporization is basically HFG is equal to, as Q is equal to M multiplied by HFG. So HFG is equal to Q divided by M, Q to water. So Q to water is 2700 kilojoule, and mass flow rate is equal to, mass is equal to 1.19 kilogram, which is given to us. So HFG, or latent heat of vaporization, is 2268.90 kilojoule per kilogram. Now with the help of HFG we can find the saturation pressure from the table. So we know that a latent heat of vaporization, this is HFG. So here pressure is at saturation pressure. So find saturation pressure at HFG from this saturated steam table. So from saturated steam table at HFG is equal to 2268.90 kilojoule per kg. So this value is not available in the table, so we will do interpolation. So HFG unit is kilojoule per kilogram and pressure unit is kilopascal. So if we check the table here if we check HFG is not available in this table, but if we check the table, steam table, so HFG two values are available, 2278.59 and 2258.02, but we have to find the pressure at 2268.9. So from the table, in front of this value pressure is 75 and in front of this value pressure is 100, and we have to find the pressure at this value. So by interpolation, third value minus first value, third value minus first value 2278.59 divided by third value minus second value, divide by, here third value minus first value divided by third value minus second value, which is atmospheric pressure. So simplify this and find atmospheric pressure, which is approximately equal to 86.77 kilopascal. So this is the end of the problem, and for more problems please like and subscribe my YouTube channel and share with your friends. Thank you.